Okay, let's begin with this question. The second option on question 12. Sometimes there's an O in this paper, QP1. So we did that earlier. So now we're going to look at the second option. Let's say you choose the second option, how to do this question. Let's move it with a little bit of a graph paper, hopefully. Not the best of graph papers, insufficient boxes there. But it's going to give an idea using this. Okay, let's try it out. So rectangle, they say with the area of y meter square, the side lengths of x and ax plus b. So that's the length and the width, okay? And a, b are constants, and x and y are the variables. Okay, so the values of y, x, and y are given in the table below. And then using the data above, in order to draw on the graph paper, the straight line, use the data, sorry, that means a straight line, draw the straight line y over x against x. So just needs a little bit of computation. Please take note the first part. What you do is just do y over x. Calculator, just divide. Just divide each of these components. Take the y, for example, the first one, I'll mention it verbally. 3007 divided by 50, it becomes 74. Okay, then the second one, 11,000 divided by 100 becomes 110. Aha. Use a different color so that we can see it easily. Okay, 110. No, the one also looks like a 1. Okay, next one, 21,600 y over x over 150. So 144. So it's 36,000 divided by 200 is 180 y over x, and then 53,500 divided by 250 is equals to 214. Okay, this is the y over x. So we need to plot it against x. Okay, so let's say we just do a sketch. I don't know if we have enough boxes here to do that, actually. Okay, let's just imagine y of x, you see the highest and lowest is like 70 to 214, 70 to 214. Okay, let's say 70, 80, 90, 200, 1, 2, difficult a bit. So must go by 50, 50. 70, 50. Okay, let's say we take this as the 50, yeah? We give some gap on it. So we have more space. Just playing around a bit. So something like this, maybe. Ta-da. Okay, let's just use this part. So we're going to measure like that. So from here to here. Okay. So the upper part here is y over x. It is 0. Let's just put let's imagine there's a continuation there. Actually, maybe we don't need the continuation. Sorry. You can just mark it as 50. I think it should be 50, 100, 150, 200, 250 again. 100, that means this is like 50, and this is like 100. It's just a bit of a crude scale. Sometimes you have a better scale on your graph paper. Just going to show the idea. Okay, please take note. It's a bit off, I think. This is like, okay. And then this is y over x. We plot it against x. So x, there's now y over x. We chose this. We're going to choose these values. X, we're going to write this ones. So you can see that 50. Also, we can do that 50, 100, 150, 200, 250, blah, 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 300 or whatever. Okay, now let's just plot the point splits. So y over x, 50, and then 74. 50, 60, 70, roughly, somewhere here, 74, 75, 100 and 110. 100 here, 110 is down here. And then 115, 144, 145, and then 40, 45 is here, 15 is that, 236,000. Sorry, 200 and reading the wrong one, 180. So 50, 70, 80. Then 250 and 214. 10, 15. Okay, let's just mark this plus. Ta-da. Okay, I'll do it in reverse because I had to draw like that. Okay, let's just make sure. Something like this. Okay. I think this need to be slightly higher. Okay, so this is an example of how to draw. Sorry about that, like this estimation like this. Okay, how to draw this. We should use a ruler. Okay, use your graph to estimate the value of A and B. So we need to understand how the equation is formed. This is a rectangle. So we're going to do a little bit of algebra here. So y equals to sideline x and ax plus b. So if I were to rewrite it, you can say that just bring the x to the left, don't multiply out. Aha. So this is something like the giant y equals to x plus c. So the gradient, as you can see, we can match the gradient to the constant a. So a is the gradient. Aha. And similarly, we can match the b directly. Usually we direct. Sometimes it could be a factor or constant, then we just do some algebra. So the constant is the y-intercept. Okay, y-intercept. Okay, let's read these two values of the graph. Let's take a closer look. The value of a. How do you do a gradient? Let's say I use the y-intercept check and just read it. This is 40. Oh, so b is easier. Let's just put b is 40 straight off. The value of a, we just need a little bit of calculation down here, please. So the value of a will be y2 minus y1 gradient x2 minus x1. Let's take two coordinates. So as you can see, x is 0, y is 40 at the intercept, or up here, this is 300, and this is, 300 and 250. Okay, 300 and 250. X and y. So 250 minus 40 over 300 minus 0. Oh, so when you subtract that, you realize that this is 210 again. 210 over 300. Aha. So 210 over 300 is, say the value is 0.7 or 7 over 10. So A is about 0.7. You can use it as a decimal or a fraction. Reduce to lowest terms. Done. So on the same diagram, draw a straight line representing the equation y equals to x squared and explain the significance. Okay, so what do they mean by that? So the y equals to x squared, actually it's not that difficult, though it looks like a fancy equation. Please take note that the y-axis is not a y, that's why we need to modify it following that, and the x-axis is x. That means basically we are plotting, rewrite this as like that. Oh, that means basically we are plotting y over x against x. So let's say we just need 2 points, because it's kind of like a straight line as well. So let's say y over x when x equals to 50. X is 50 means x equals to 50. Then the y over x is 50. You can see that is equals to x1. 50, 50. It just follows the value of x, in other words. So what I'm trying to say is 50 here is 50. So another point, please, like that. Let's say we take a bit further away. X is 250. We put x is 250. I don't even need to calculate. You know why? This becomes 250. This whole thing equal to that. Can you see that? The y of x, I don't even need to calculate. It's going to be equal to that. So 250, that's so 250. Meaning that, so 250 is here. This is 250. Ta-da. Okay, significance. Okay, let's just draw like this first. Okay, so this is the plot of this line. The green one. So on the same diagram, we drew the line representing this and explained the significant value of x given by the point of intersection. So when they talked about the point of intersection, when they're talking about this point, as we can see from the graph, is 150, 150. It is when the, what is the word? The rectangle is a square. How do we know that? Because y is x squared. That's an area of a square. X is equal to x, x times x. One side is x, the other one also is equal to x. So that's it. It's a square. Okay, at that point, rectangle becomes a square. Okay, square is a subset of rectangle, not the other way around. So now state the value approach, last part, the ratio of the two sides of the rectangle as x becomes increasingly large. So this is just a limit question. Maybe I'll do up here due to insufficient space. This side, let's pull this up, this equation. Ta-da! Basically, they're asking limit of x tends to infinity for y over x. Aha. So the same as evaluating is x become increasingly large. Okay, x tend to infinity. Let's just write that and say by the ratio of the two sides. Sorry, not this one. They're talking about the ratio of the two sides. Made a mistake on the interpretation, sorry. So ratio of the two sides means limit of x tend to infinity. Oh, so let's say the ratio of the two sides, in this case, should be in the order of the larger. So the larger part of the fraction, ax plus b is one side. The other side is x. So we rewrite it like this. So the constant x tend to infinity of a plus b over x. You can see that the b over x part as 1 over x, and this part b over x will tend to become infinity as 0, because x become bigger, divide by a big number, you can say it becomes 0. So in other words, the a part constant doesn't change, plus 0, or in other words, just a. So state the value approached by the ratio of these two sides. So the answer is just a. And the a value we found earlier as 7 and 10, or 0.7. So it approaches the value 0.7, the ratio itself. Thank you.